In last week's video, we took a look at the GABA A receptor. This time, we'll focus on the GABA B receptor. The name is similar, but as you can tell just by looking at the structure alone, the way they work is very different. GABA A is a ligand-gated ion channel. GABA B, on the other hand, is a G protein coupled receptor. This animation focuses on the GABA B receptor located in a synapse of a postsynaptic neuron. However, GABA B receptors can also be found in other locations where they perform different functions. While GABA A receptors use chloride ions to modulate the membrane potential, GABA B has this effect by changing the potassium ion concentration. Potassium is positively charged and is more abundant in the cytoplasm compared to the extracellular space. Therefore, releasing potassium into the extracellular space makes the cytoplasm more negatively charged. Let's have a look at the structure of the GABA B receptor. The receptor has two subunits, subunit 1 and subunit 2. These two subunits are held in close proximity by coil-coil domains in the cytoplasm. When the neurotransmitter GABA floods the synaptic cleft, GABA can bind to the binding pocket of the subunit 1. This changes the conformation of both subunit 1 and 2. A G protein can bind to the subunit 2. The G protein consists of the subunits G alpha, G beta, and G gamma. Lipid modifications on the alpha and gamma subunits allow the proteins to be anchored to the cell membrane. When the G protein binds to the receptor, GDP and G alpha can be replaced with GTP. This activation causes the G protein to leave the receptor, and G alpha separates from G beta and G gamma. In this step, a signal amplification can take place as one receptor can activate multiple G proteins. G beta gamma can then diffuse along the membrane and bind the potassium channel GERK. GERK is a tetramer and has 4 binding sites for G beta gamma. By binding, the G beta gamma facilitates the opening of GERK. Potassium ions can flow out of the cell. The channel is deactivated when G alpha hydrolyzes its GTP and picks G beta gamma back up. The final thing I want to touch on is GABA B desensitization. KCTD12 can be bound to subunit 2 of the receptor. It can capture activated G alpha beta, thereby stopping them from interacting with GERK.